In this class, we're going to go over questions on motion under gravity. Okay, let's start with the first question. Calculate the maximum height a ball of mass 1.2 kg will attain if projected vertically upward with an initial velocity of 17 meters per second. Okay, let's start by writing out the information that we are given in the question. We are given that the mass of the ball equals to 1.2 kilogram. You understand? And then we are given that the initial velocity is what? Initial velocity u equals to 17 meter per second. Okay. Now we are asked to calculate the maximum height. H is unknown. So now let's quickly draw a typical diagram here. Let's say this is the ball. You understand? This ball is projected upward. You understand? Vertically upward. Now, in our previous class, I told you that when an object is moving against gravity, it will go to a maximum height before it starts declining. The maximum height here, the velocity at that point is what? 0. You understand? If I imagine, look at this marker. If I throw this marker up, it will go to a point and then it starts declining. It cannot travel upward again because the velocity has declined to its barest minimum, which is 0. The velocity at the height here is what? 0. Do you understand? So the velocity of the object is 0. The final velocity to be specified, okay? The final velocity at the peak, at the highest point is what? 0, okay? Now, having known that the final velocity is 0, I gave you two conditions for equation of motion under gravity. If we have an object traveling upward, are you paying attention? The body is moving against gravity. Do you understand? Now, because the body is moving against gravity, the value of acceleration due to gravity will be what? Negative. Do you understand? Just pay attention. You know, in the question, we are not given the acceleration due to gravity. Whether you are given an acceleration due to gravity or you are not given acceleration due to gravity, just know that anytime you are dealing with equations under motion under gravity, the acceleration due to gravity is 10 meters per second squared. So A equals to, you can call it G, you understand, or G. Let's call it G because we are dealing with gravity now. G equals to 10 meters per second squared. And in some case, you can use 9.8, you understand? Okay, now back to the question. Because the body is moving against gravity, the value of G will be what? Negative. And I gave you two conditions for equation of motion under gravity. The first condition is for a body traveling upward. You understand? For a body traveling upward, the equation is V equals to U minus GT. H equals to UT minus half GT squared. You understand? Okay? And the last equation is V squared equals to U squared minus 2GH. You understand? This is for a body traveling upward. That is, the body is moving against gravity. So now, for a body moving under the moving towards gravity, you understand? Let's assume that a body is thrown from an height. For example, let's say I throw this marker downward. This one is a downward motion now. The body is moving towards gravity. So the equation becomes like this. V equals to U plus GT. Because the acceleration due to gravity now is positive. You understand? So H equals to UT plus 1 over 2 GT squared. Okay? And V squared equals to U squared plus 2GH. You understand? Now, the acceleration due to gravity is positive because the body is moving towards gravity. It's not moving against gravity now. Okay? Now, we are told in the question that the ball is thrown up, so the ball is moving against gravity. Hence, we are going to use one of these equations to determine the maximum height. Do you understand? Now, looking at the parameter that we have here, which of these equations are we going to use? We are given the initial velocity. We are told to calculate the height. We are told to the final velocity is what? 0, and the acceleration due to gravity G equals to 10 meters per second squared. Now, we cannot use the first equation, and the reason is because there is no H, and H is the parameter that we are asked to calculate. Now, which equation are we going to use among these two equations? We are going to use the third equation. The reason is because in equation 2, we are not given the time, okay? In the question, we are not given the time. And the time is another parameter that is present in equation 2. So I'm going to use the third equation. Do you understand? Okay. So using the third equation, we are going to have v squared equals to u squared plus, negative now, minus 2gh, because the body is moving upward, is moving against gravity. Now v is what? 0. So I'm going to have 0 squared equals to u squared. U is what? 17 meters per second. So I'm going to have 17 squared minus 2 multiplied by g. G is 10 multiplied by h. Do you understand? 0 squared is 0. So I'm going to have 17 squared is 289. 289 minus 2 times 10 is what? 20. So I'm going to have 20h. Do you understand? Okay. If you move 289 to the other side of the equation, it becomes negative 289 equals to negative 20h. Divide by negative 20. So h equals to 14.8. Okay, 14.45. Okay, 14.45 meter. This is the height that the ball will attain. Do you understand? Okay, that is the solution to the question. Now let's move to another question. Question 2. An object falls freely from a height of 25 meters onto the roof of a building 5 meters high. Calculate the velocity with which the object strikes the roof. Okay, please, I want you to pay attention. Let's start by writing out the information that we are given in the question. We are given that an object freely falls from a height of 25 meters. So the first parameter here is what? Height, which is 25 meters. Do you understand? Okay? Onto the roof of a building of 5 meters high. Okay, the height of the building, let me call it like that. The height of the building is what? 5 meters. Okay? Calculate the velocity with which the object strikes the roof. The velocity. Now, the velocity with which the object strikes the roof. Let us try drawing a diagram. Okay? An object falls freely from an height. Let's say this is the object. Okay? This is the roof of the house. This is the house. This is the roof. You understand? Now this object falls freely from this height. The height of the object now is what? 25 meters. You understand? Now, don't forget, in our previous class, I told you, when an object is released or falls from an height, the initial velocity of that object is what? 0. You understand? Pay attention. When an object is released or falls from an height, the initial velocity of that object is 0. Do you understand? So the initial velocity of this object u equals to 0. Do you understand? So I'm going to have here u equals to 0. Now, don't forget, I told you when we are dealing with motion under gravity, the acceleration due to gravity is always present and is constant. You can use 9.8 meters per second squared or 10 meters per second squared. But because we are not given in the question, I'm going to use 10 meters per second squared as the acceleration due to gravity. G equals to 10 meters per second squared. Now, we are given all these parameters. We have h, we have velocity, we have u, and we have we are told to calculate the final velocity, and we are asked to calculate. We are given that the u equals to 0. You understand? And g equals to 10 meters per second squared. Now, because the object is released, this is the downward motion. You understand? So I'm going to use one of these equations. Do you understand? You know, the object falls downward. It falls freely downward, and it hits the roofs of this house. Now, because this is the downward motion, I'm going to use one of these equations. Now, the parameter that I have here will depend on which of these equations I'm going to use. Now, let me ask you, which of these equations are we going to use with respect to this parameter? Of course, we cannot use the first equation, and the reason is because we are not given time in the question. Now, let's look at the second equation. Also, I cannot make use of the second equation because we are not given time in the question. Now, I will use the third equation. This is the equation that is suitable to calculate the velocity. Now, before we proceed, you know that the height at which the object falls is what? 25 meters. Now, we are given that the height of the building now is what? The height of the building is what? 5 meters. Because the height of the building is 5 meters, the height that I'm going to use to solve this question will be 25 meter minus 5 meter, because the ball does not touch the ground level. This is the ground level. Okay. Now, because the ball does not touch the ground level, the distance between where it touched, which is the roof of the building, and the ground level is what? 5 meter. Now, because the ball does not cover this distance, I'm going to subtract the height minus what? 5 meter. I'm going to subtract this height from 5 meter. Do you understand? So the height now is what? 20 meter. Those are the important tips that you have to pay attention to when you are dealing with questions, especially when you are solving this in exam. Okay, don't go and use 25 meter directly. You won't get the right answer, and you will see like the very possible option when you use 25 meter, and you think you get the answer. That's not true. Do you understand? So you pay attention to every details in the question that you are asked to solve. Okay, let us use the third equation. The third equation is v squared equals to u squared plus 2gh. You understand? Now v squared equals to u squared. U is 0, so I'm going to have 0 plus 2 multiplied by 10 multiplied by h. The h here now is what? 20. Do you understand? So v squared, please pay attention, v squared equals to 0 plus 10 multiplied by 2, 20. 20 times 20 is what? 400. So I'm going to have 400. So v equals to the root of 400. So v equals to 20 meter per second. You understand? So that is the velocity at which the ball, the object, strike the buildings, the top of the roof of the building. Do you understand? That is the velocity at which the object strike the roof of the building. So let's move to another question. Okay. A carpenter working at a construction site mistakenly drops his hammer from a height of 125 meters. How long does it take to reach the ground? Okay, that's question number 3. You understand? Now let's start by writing out the information that are given in the question. You are given that the hammer is dropped from a height of 125 meters. 125 meters. Now we are asked to calculate the time it will take to reach the ground. So t is unknown. Okay. Now you see, now in this question we are not given the acceleration due to gravity g, but we know that g equals to what? 10 meters per second squared. Okay. Now how do we determine the time? Let me quickly draw. Let's assume that this is the carpenter. Okay. The carpenter is holding this hammer. This is the hammer that the carpenter is holding. He mistakenly draw this hammer. You understand? The height of this hammer to the ground is what? 125 meters. Now, don't forget, in our previous class, I told you that when a body falls from an height, the initial velocity is what? 0. Do you understand? When a body falls from an height, the initial velocity is what? 0. So, having known that the initial velocity is 0, u equals to 0. Now, with respect to the parameters that we are having here, which of these equations suited these parameters? Can we use the first equation? If you want to use because this is a downward motion, if you want to use the first equation, we are not given the value of the final velocity. So we cannot use the first equation. Let us check the second equation. We are given the h. H is what? 125 meters. We are asked to calculate t. T is also present in the equation. We know that u equals to 0 because for an object that is falling, you understand? When an object falls from an height, that means the object's initial velocity is 0. So we know the value of u as 0. We know that g equals to what? 10 meters per second squared. Hence, we can make use of this second equation. You understand? Now, let us check the third equation. The third equation is v squared equals to u squared plus 2gh. We cannot use the third equation. The reason is because we are not given the value of the final velocity. You understand? So, the best equation that suited this, that goes with these parameters that were given in the question is the second equation. Do you understand? So, h equals to ut plus 1/2 gt squared. Okay, h equals to u is 0 multiplied by t plus 1/2 multiplied by 10 multiplied by t squared. You understand? Okay, h equals to 0 plus 1/2 multiplied by 10t squared. Do you understand? Please, I want you to pay attention. So h equals to 1/2, okay, 10t squared all over 2. H equals to 125 meters. So I'm going to have 125 here. 125 equals to 10t squared all over 2. You understand? Now I'm going to cross multiply. Okay, if I cross multiply, I'm going to have 125 multiplied by 2. That is what? 250. Okay, so I'm going to have 250 equals to 10t squared. So I'm going to divide both by 10. This over 10 and this over 10. That means I'm going to have t squared equals to 10. T squared equals to 25, because this 10 divided by 250 is what? 25. So I'm going to have t squared equals to 25. So I'm going to take the square root of both sides. So I'm going to have t equals to 5 seconds. So the time it takes the hammer to touch the ground is 5 seconds. Okay, what I did here is that I just square both sides. So I take the square root of 25. Okay, I take the square root of both sides. If you take the square root of t squared is what? This square will cancel this square. So I'm left with what? T equals to square root of 25. And the square root of 25 is what? 5. So t equals to 5 seconds. That is the time it takes the hammer to reach the ground. Okay, so that is the solution to that question. That will be all for this class. In our next class, we're going to proceed with more examples. See you in the next class.
To watch the next class, kindly check the description of this video. You are going to see a link there. Click on that link, or you should check the playlist on this channel. Okay, see you in the next class.